Good afternoon and welcome to 2021. For my first video of the new year, I'm going to show you how simple graph plotting can be in Silverfrost Fortran 95. So what I'm going to do over the next half hour or so is develop a simple Fortran program which shows you how to plot a graph. So I'll begin by creating a new file, and for the purposes of this demonstration I'm going to use a module, and all the variables and functions are going to be stored in that module. So I've created the module demo mod, and I like to use the implicit none declaration. And because I'm going to be plotting graphs and I'm going to use double precision real variables, I'm going to set up an integer value which defines the kind number associated with double precision reals. There we go. Now I'm going to add a simple function, and that function is going to be called GUI. So I need to put that within the contains section of the module. And this integer function GUI is going to return a value of 1. Okay. Now this integer function GUI is going to be the main function which builds our window and displays our graph. We need to call this function GUI from our main program. So I will now add the main program. So I want to call the function GUI from within the main program. So the value of 1, which is returned by GUI, is assigned to the integer I. But because I've used implicit none, I need to define the I as an integer. And I also need to tell the main program where it is going to find the function GUI. So I need to tell it to use the module demo mod. So we now have a few lines of Fortran which I think should compile and run. So I save it, and it has run. We have opened a terminal window and the program has finished, and the press return to close window message tells us that. So let's print out the value of I, which is returned after the call to the function GUI, and let's just put a print message in the function GUI to tell us that it is running. So let's see what happens when we run this now. So you can see the main program calls the function GUI. The function GUI prints this message to the screen. We finish the function GUI. The value of 1 is returned to I, and the main program prints I, which is 1, as you can see here. So the main program is now successfully calling the function GUI. Now, I don't want the function GUI to print messages to a terminal window. I want to create a window. So I'm going to do that by issuing a simple winio command like that. I'm going to do away with that print message because we know that's working, and I'm going to do away with this print message because we know that's working as well. And I'm now using the ClearWin library, so I need to tell the module demo mod where it is going to find these ClearWin instructions. So I need to use ClearWin. Right, let's see what happens now. I've got an error because I've introduced this new variable IW and I've not defined it. So let's add that to the function. Fingers crossed this should run this time. So now you can see that we've opened a small window, but there's nothing in the window, and we're still opening a terminal window. So let me close that new window, and at that point the program terminates, and we can see that in the terminal window. Let me add the WinApp directive to the beginning of the program, and this will prevent the terminal window from opening. And now I'm going to add something to this winio call, which will create a small menu bar on top of the new window, and it will have the message exit, and it will allow us to exit the new window in a controlled way. So I use this %mn for menu format code, and the label that appears in the window is exit, and that maps on to a special callback function called exit. And let's see if that works. Yes, so we now have our window and we have our exit menu, and we can click on the exit menu and exit the program. Now I said at the beginning I wanted to plot a graph. So the first thing we want to know is the number of points that we wish to plot. So let's create a message in our window which asks the question how many points to plot. Right, let's see if that works. So now we have the question, how many points to plot. And we need to tell the program a number. So in order to do that, we need to define an integer which will contain that number. I will call that integer n, and I'm going to initialize that value of n to 10. And then to display an edit box where I can change the value of n, then I need to use the %rd format code, which is essentially an integer edit box. And associated with that integer edit box, I have to have the name of the variable which it is associated with, which in this case is n. So let's see what happens when I try and run this now. So how many points to plot? As before, we now have a box, and you can see the initial value of the box is 10, and I can change that to 100 or 1000. I can make it minus 1000, so on and so forth. So let's modify this and put a space between the question and the edit box. And we can do that quite simply by putting a tab between the end of the string and the edit box. That looks okay now. The problem with this is that the background colour of the window is the same as the background colour of the edit box. So let's change the background colour of the window, and we can do this by adding the %bg format code, and that simply tells us that tells the program we're setting the background colour, and we have to give that a value, and I will give that the RGB value 200, 200, 200. So that's going to be a light grey type colour. Let's see if that works. Yes, it has. So we now have a light grey background. But the problem is we really want this box to be a different colour. So we can use the %bg with a grav accent, and that tells the program that the colour that's being specified is associated with the next control, and the next control is this %rd box. So what I want to do is to put percent background with the grav accent, and I want to make it white, and because white is one of the sort of standard colours, I can just put the string white as an option to the %BG format code. So let's run that and see what happens. And now we have the window is coloured grey and the %RD box is now white. So we're making some progress. Now, because we're plotting a graph, then the number of points that we plot are important. At the moment we're saying we're going to plot 10, but we need to set a maximum number of points to be plotted, and we need to set a minimum, and obviously that minimum number can't be negative. So a reasonable value for the minimum would be 2. So what I'm going to do is I'm going to define two parameters, nmin and nmax, and I'm going to set them to 2 and 100 respectively. Now, what I want to do is to limit the values which the user can type in to this integer edit box. And I do that by adding the %IL, which specifies the upper and lower limits for the following integer edit boxes. So in this case, these integer limits are of course nmin and nmax. So I add these to the WINIO statement. Let's see what happens. So the size of the edit box is now reduced, and you can see that I can put a minimum value of 2 in. If I can put 20 in. If I try and change that to 200, then the program limits what I can enter to 100. But there is a problem here. If I want to try and enter 10, if I delete that 2, I enter 1, and before I've entered the following 0, the program has said you're entering bad data, and it's reset it to the minimum of 2. So one way to get around this is to put a spin wheel on this integer edit box. So let me do that. So I'm going to add, after the IL format code for the limits, I'm going to add another format code, %DD, and I'm going to associate the value of 1 with that, and now you'll see that I now have this spin wheel, and I can spin all the way down to 2 but no further, and I can spin all the way up to 100 but no further. So I now have a way of adjusting the number of points which I want to plot. Okay, so I want to plot a graph. So I need to have x and y variables which go on to my graph for plotting. So I will define these as module variables, and as I said earlier, I'm using double precision for the real values. So I'm defined the kind number for double precision arithmetic as dp, and let's have an array called x, and it makes sense for that array to be indexed from 1 to n max. And I could have another array called y, also indexed from 1 to n max. And it's a good idea to initialize these arrays to an initial value. So I'm going to set those initial values to 0. The wee typo in there, so solve that. Right, let's see if that compiles. No errors, that's fine. So at the moment, you've seen that the program has a question mark and a little edit box. What I want to do now is I want to draw a box around those two items. So to do that, I'm going to add the command to open a box, and for every open box command I need to have a corresponding close box command. Right, let's see what that's done. Okay, so you can see that we've now drawn a box around these two items. Now, I now want to add another box below this first box. Now that's okay. Right, what's happened here is I need to add an ampersand there, and that will go away. Close, yeah, right. So I want to have one box across and two down, which means I need to add another close box command. Let's see what happens now. I've only got one box, but I asked for two. But the point is, the second box doesn't contain anything. I need to put something into the second box in order for it to appear. So let's just put some text into the second box. I made a mistake, I've forgotten my ampersand again. There's my second box. Now this is where I'm going to put the graph, which is going to show the data which is in the arrays X and Y. So how am I going to add this graph into the second box? I'm going to use another format code called %PL, and there's a few things I need to do with this. I need to use a command called xArray and an ampersand, and the PL is going to draw into a graphics region, so I need to specify the size of the graphics region, which I will say is 400 in the X direction, 400 in the Y direction. I need to tell the PL the number of points which are being plotted, which is N, and I need to tell the PL the name of the X and Y arrays. So if I now run the program, you can see we've created a graphics region. The graphics region doesn't yet contain a graph, but remember, all the values in the X and Y arrays are currently 0. So I need to, first of all, change the values in the X and Y arrays. So to do this, I'm going to add a button to the window. I'm going to place the button after the integer edit box. So I'm going to put another tab in, and I'm going to add a button, and the button is going to have inscribed on it the message plot. So let's see if that works. So there's my button which says plot. Now at the moment I haven't associated this button plot with any functions, and if I click on plot, the window will close, as you can see. So what I want to do is I add the claret modifier to the %bn, and that basically says when you click on this button you call a callback function, and I need to give the name of that callback function, which I'm going to call plotcb. Now there's no point in me trying to compile this program at the moment because I haven't defined plotcb. So let's do that now. So let's define an integer function, plotcb. Let's have it return a value of 1, and there we go. That's now defined that function. So just to show this working, I'm going to put a print message in here to say starting plot CB. So let's see what happens when I run the program now. So everything's the same as before. I now click on plot, my output window opens, and I get this message, start plot CB. So that shows that the button is associated with this callback function. This output window is, this large white output window is opening instead of the small black terminal window because I added the WinApp directive at the beginning of the program. So we're now in a position where when we click on the plot button, we run this plot callback function, and we can use that function now to define the values in the X and Y arrays. Okay, so let's use a do loop to define the values in the X array. So let's say do I equals 1 to n max in steps of 1, and do x of I is equal to I. Now I is starting from 1. We really want x to start from 0, so let's just put a -1 in there. We might need a type conversion, so that's an integer. Let me just put the double in there. Don't think that's necessary with Silver Frost, but I'll put it in anyway. And the graph that we want to plot is y is equal to x squared. So let's put y of I is equal to x of I times x of I. So how can we check that this is doing what we think it should do? Well, let's just put a print statement in there for the moment, and let's just print I, x of I and y of I. So let's see what happens now when we run the program. I must appear in a type. Okay, so I've used implicit none. I need to define an integer I there. This should work. So if I click on plot, hopefully this do loop will execute, which it has. If I click on plot again, the do loop will again execute. Now, I don't need that. I only need to execute the do loop once, because I only need to define the variables in the X and Y arrays once for the purposes of this example. So let's modify the the function slightly. Let's add a logical value called first and set it to true, and then say if first, so if first is equal to true, then do all that. And once you've done that the first time, set first to false. Right, let's just sort out the spacing. So if this is the first time the program runs, and first is initially true, it will run around that do loop. After the do loop, it sets first to false. So the next time the routine is called, first will be false, so it won't do this. Let's just see if that works. The first time I click on plot, we go through the do loop. The second time I click on plot, we don't execute the do loop. So that's fine. So let's take out these print statements now because we don't need them. Right, all we need to do now is, after we have calculated these values in the X and Y arrays, then we want to tell the graphics region, which contains the plot data, tell it to be updated, and we can do that by using a call to this subroutine, simple plot redraw. Right, let's see what happens. So same as before, we now click on plot, we go through the do loop, that updates the variables X and Y, then we call simple plot redraw, and at this point our graph appears. And if we change the number of points and click on plot again, then you can see that the graph is updated. But it's not really a very nice graph at the moment, so let's see if we can improve its appearance. So let's go back to this command where we create the plot region. So we might want to add a title to the plot. I like to put grid lines in a plot, and I also like to draw a box around the plot. We might want to make the line that's being drawn in the graph a different colour. And we might want to make the line width a little bit thicker, and we might want to draw a symbol at each of the data points. So let's see what that looks like. I'll click on plot, and you can see that's a much better graph. We have a frame, we have grid lines, we've covered in the line which is joining the points together, and we've labelled the data points. And there are other things which we can do. We can change fonts and so on. So now every time I change the number here, I can click on plot and the graph is updated. Now what I really want to do is, instead of having to change this number and then click on plot, it would be nice if the plot would be updated automatically every time I change the number. And I can do that by adding a callback function to the %rd, which is the integer edit box. And the callback function is the same callback function as is linked to the button, and that is plot CB. So after %n, which is associated with the %rd, I need to have another plot CB. So this first plot CB is associated with this %rd with a claret, and this plot CB is associated with the button. So let's see that in action. I click on plot as before, but now if I click on the number of points n, you can see that the graph is automatically updated without me having to click on the plot button. So the plot button now becomes redundant, so I can take that out. So I remove the callback associated with the plot button, and I remove the button itself. So we draw the graph by changing the input. So this works fine, apart from the fact that when the window is initially created, we have a blank graph. It would be nice if we could display the window with the graph initially drawn, and we can do that quite simply. We add another callback, and what we do is we use another format code, which is SC, which means start callback, and when the window is first formed, then we immediately call the startup callback, which in this case is plot CB. So if I demonstrate that, you can see now that as soon as the window is formed and displayed, then the graph is plotted before the user has changed the input number of points to be plotted. So we can change these input, and we can update the graph in a quite straightforward manner. So this video has shown how a very simple GUI can be developed very quickly, and a graph can be embedded within that GUI and its values updated under program control very easily within Fortran 95. If you look at the code, you can see that the actual process of plotting the graph is all achieved with one single line of code. And I think that this is a very powerful tool for any type of engineering analysis where you have to do calculations, but at the same time you have to view the results in a graphical format. I find this %PL format code very powerful for achieving that. So I hope you found this first video of 2021 interesting and informative, and I look forward to sharing my thoughts with you on some other things later in the year. If you have any comments or suggestions, please do leave them in the comments box below this video. Thank you and have a good day.